Hello, welcome to lesson 6 in our series on introducing Python for beginners. You've learned how to make working programs. In this lesson, you'll learn how to make your programs more user-friendly. So in this lesson, we'll look back at what we've learned about writing programs and seeing the output in the shell. You'll learn what user-friendly means, and you'll learn to make your programs more user-friendly in their inputs and in their outputs. So to recap, Python programs can be described by what we call the IPO model. That is, we can think about what values the user will input, how those values are processed, and what results are output at the end. User input in the kind of Python that we're doing at the moment is done in the shell by the user typing something with the keyboard. And the output similarly is displayed in the shell for us to see the results on the screen. If a program is user-friendly, both the inputs and the outputs are well designed to help the user to make it easy and pleasant for them to use your program, unlike the gentleman in this picture. Here's an example of a program that works, but the person who wrote it hasn't thought much about making it user-friendly. This program calculates the area of a triangle. Base and height are input. That's the input part of IPO. Area is calculated as half the base multiplied by the height. That's the processing part. And then the area of the triangle is output. There aren't any errors in this program. If we ran it, it might look something like this. Here I've entered 32 and 7.4 and it's given me an area of 118.4. But you can see that this isn't a very user-friendly interface for the program. It's not clear what you have to enter and it's not clear what the output is. So let's see how we can improve this program. Here's a much better interface for the same program. Let's just stop and think about that word I've just used, interface. Interface means the system that allows the user to interact with the program, with the software. So that is basically the input and output of the program. So you can see that this is a much easier to understand. It's got a heading that tells you what the program does, calculate the area of a triangle. Instead of saying enter value 1, enter value 2, we've told them what to enter, the size of the base in centimetres, the perpendicular height, and we've output the result, and it says the area is, and then a result, and then the units, that's in square centimetres. So all in all, it's a much improved interface, and this is much more user-friendly than what we saw on the previous page, although it's the same program. The input prompts are helpful. They tell the user what to type in, and the outputs are explanatory. There's a message that explains what you are seeing. So, what's user-friendly? It means that the inputs are well designed and the outputs are well designed. What does it mean for the inputs to be well designed? Well, we should include prompts to explain to the user what they have to type in. And we also need to try to prevent them making errors. I'm going to talk more about this on the next slide and in later lessons. And how can we improve the output? Well, we can add explanations so that the user knows what it is that we're showing them. And we can also choose whatever level of precision is appropriate for the user's needs. So I've already looked at prompts and explanations. Let's have a quick look at errors and precision. So in this program, I've added an extra line, the second line of the code you see here, and I've rounded the area down to 2 decimal places. So the output will come out as 48.3 instead of the very long number with a huge number of decimal digits after the decimal point. The degree to which I can round my answer up or down will depend on what I'm using it for. If I'm doing a scientific experiment, it might be really important to keep everything exactly precise to the very final decimal point, no matter how big that number is. In other cases, I might just want a general correct answer, and rounding it to 2 decimal places is enough. So in this example, I have rounded the answer to 2 decimal places. I've used a new function called round. Can you see that second line? Round is a function. It's in purple. That shows it's an inbuilt Python function, and it takes 2 parameters, the number that we want to round and the number of decimal places to round it to, and it will either round it up or down. Here's another example of the user entering a value into the triangle program, and here the user's made a mistake. Instead of typing an integer, they've typed the word 4. We didn't actually tell them they had to write it as integers, and you can see that that's created an error straight away, because the next line of the program is to convert the height to float data type, and the computer doesn't know how to convert the word 4 to float data type because it's a string, it's not digital. So that's caused an error. And that's something else we want to avoid when we make our programs user-friendly. We want to avoid the program crashing, because that's another way that we might frustrate the user. In this example, the user has entered data of the wrong data type. So we can help them to avoid it. And there's a number of ways to do this, but let's just look at one of the simplest. We could simply print a warning sign. So under the line that says this is the area of a triangle, I've written a warning, enter number values only. The final line there, print \n, that throws a blank line. So when we run the program, it says area of a triangle, warning, enter number values only. There's a blank line and then the input part of the program. This isn't the only way to stop the user entering incorrect data. We can actually write code so that the program will only carry on if they've entered the right value, and we will be learning that over the next few lessons. But for now, I've just put in a message to the user, and that is always a useful thing to do. So I've just reviewed some ways that you can make your programs more user-friendly by thinking about both the inputs and the outputs. Why go to all this trouble to make your programs more user-friendly? Well, obviously, a program that's more user-friendly is more accessible. It's easier to use. The user is likely to make fewer errors. They're likely to be happier with your product. If they're your customer, or perhaps if it's your boss at work who's asked you to write the program, they'll be more satisfied with it. And if you want to be a successful professional programmer, you will be more successful and you will make more money if your programs are user-friendly. In general, if you want to share your program with anybody else, then making it user-friendly is always a good investment of your time. Let's just go back over how we can make sure our programs are user-friendly. Think about, this is the most important thing, think about the user and what their experience is when they use your program. include prompts for the inputs you need, help the user to avoid errors, and present the outputs in a format that reflects how they're going to use the result. Do they need a huge amount of precision? Is rounding it to the nearest decimal place, is that going to be okay? As I said before, just think about the user and what you can do to help them, and then your programs will be user friendly. Let's just recap. We learned 2 new Python commands today. The round function, that's a built-in Python function. It takes 2 parameters. The first is a number of the float data type, that is a number with a decimal place in it. And the second is an integer that tells you how many numbers you want after the decimal point. And it will, remember, every function returns a value, so the returned value will be the number that you started with, but rounded to a certain number of decimal places. And the second thing that you learned was \n, which is a way of printing an empty line on the screen, and that helps you to space your work out a little bit. So here are some programs that we've looked at before: inputting days, hours and minutes, and outputting seconds, inputting seconds and outputting days, hours and minutes, and calculating simple interest, which I'll bring that up in a moment on the next slide. So go back to these programs if you've written them already, or write them for the first time if you haven't yet, and make them as user-friendly as you can. Here's the formula for simple interest. You can see that the inputs are called P, R, and T, but those aren't very helpful things for the user. So in creating a program to do this, you're going to have to write better input prompts, write messages to prevent errors, and produce the output in a format that people can understand. You'll have to think about whether you want the user to type in the rate as a percent, like 50 would 50%, or as a decimal, 0.5 would be the same as 50%. So you're going to have to think about which of those 2 types of input you want, a whole number or a decimal, and treat the input value accordingly. So it's a slightly harder than it looks to get this absolutely right. Think about the user experience. In the next lesson, I'll talk about how to make your programs more readable by other programmers. So see you in the next lesson. Bye for now.